Hello dear friends, welcome to this fifth lecture of NMAT. In this we are going to start a new topic, the topic of solving or solution to the system of linear equations. Earlier we have studied how to solve a linear or an algebraic or transcendental equations. We have discussed bisection method, we have also discussed regular falsy method, we have discussed successive approximation method, and we have also discussed the Newton-Raphson method. These four different methods we have discussed. Now, in this also system of linear equations there are four methods, in which these two simplest methods we are going to study here. The methods they are namely, first method is the matrix inversion method and another method is Gauss elimination method. This is the system of equations. System means more than one equation. There are three equations involved over here. In this system has three equations in three unknowns. Unknowns are denoted by x, y and z. So I am now illustrating first the matrix inversion method. Solution by the same system we shall solve by Gauss elimination method also. At the outset, we shall express this system, three equations, in the form of a single matrix equation. We know this, how to express this, we have already studied this. This system of equations is denoted by rewriting the given system in matrix form, in matrix equation form, of course. The given system can be rewritten as the coefficient matrix 2, 3, minus 7. The coefficients of x, y, z, the second equation 4, 4, minus 3 and 2, 3, 2. This matrix is called as matrix A, which is coefficient matrix multiplied by the matrix of column matrix of unknowns, that is equal to the value matrix of the right hand side, 5, 3 and 2. So I have written this given system in the form of the matrix AX equal to B, where capital A is the coefficient matrix of unknowns, namely 2, 3, minus 1. Second equation 4, 4, minus 3. And third equation is 2 minus 3 plus 2 into capital X matrix of column matrix of unknown equal to capital A. This is the single matrix equation which involves all the three linear equations. Now, what is the matrix inverse equation from this equation? If I left multiply by A inverse into AX equal to A inverse into B. So this gives me capital X. This is matrix of unknown equal to A inverse B. This is nothing but the matrix inversion method. The solution is obtained by equating or by finding out this matrix A inverse into B. So you need to determine the inverse of coefficient matrix capital A, multiply it by this column matrix capital B, and whatever this matrix product comes, that is your matrix of unknown. So we shall now determine A inverse number 1, and afterwards we shall take this product A inverse B. So what is A? What is A inverse? A inverse, we know that is equal to 1 upon determinant of A into adjoint of A. So we shall evaluate this inverse by this matrix. So what is determinant of A? Determinant of A is equal to 2 into 8 minus 9 minus 3 times 8 plus 6 minus 1 times minus 12 minus 8. So determinant of A is minus 2, 14 minus 42 plus 20. So minus 44 plus 20, it is minus 24. So determinant of A is equal to minus 24, and hence you can say that it is a non-singular matrix, and consequently therefore the inverse exists. Now the question is how to obtain this matrix adjoint of A. Now, to determine the adjoint of A, I shall provide you the simplest method of finding out the adjoint of A. The method is rewrite the matrix capital A. 2, 3, minus 1, 4, 4, minus 3, 2, minus 3 plus 2. I am providing you a very quick method of finding out the adjoint of matrix A very quickly. Now, just rewrite the matrix capital A. Now, adjoin or append first two columns here. What are the first two columns? 2, 4, 2 and 3, 4 minus 3. What I did? I have added here two columns. Now, after addition of not addition, perhaps adjoining these two columns, now adjoin two first rows. What is the first row? 2, 3, minus 1, 2, 3. And second row is 4, 4, minus 3, 4, 4. Now you have almost obtained the adjoint of A. Now adjoint of A is equal to, now delete this first column and first row. Now write down the minus like this. You go column wise. This go minus 8 minus 9. 8 minus 9 is minus 1. You go column wise and write the minus row wise. The second minor is 3 minus 6. 3 minus 6 is minus 3. Then minus 9 plus 4 minus 5. So this is minus 9 plus 4. And then second row is taking this minor. Minus 6, minus 8, minus 14. Again row, go column wise and write the minus row wise. 4 plus 2, 6, minus 4 plus 6 minus 4, 2. Again go column wise. Minus 12, minus 8, 6 plus 6, 12, and 8 minus 12 minus 4. So this is your, what we say, the adjoint of capital A coefficient matrix formed by this a very quick method. So therefore A inverse is equal to 1 upon determinant of A, 1 upon minus 24 into adjoint of A is minus 1, minus 3, minus 5, minus 14, 6 plus 2, minus 20, 12, and minus 4. And by this formula, hence capital X is equal to A inverse inverse B, A inverse we have just found, it is minus 1 upon 24 times the adjoint of A, minus 1, minus 3, minus 5, minus 14 plus 6 plus 2, minus 20, 12, minus 4, multiplied by matrix capital B, this is capital B matrix, which is 5, 3, 2 column matrix. So, matrix X means the column matrix of unknowns X, Y, Z. So, from this, X is equal to minus 1 by 24 times minus 1 into minus 5, minus 5, minus 9, minus 10. Minus 10, minus 24, minus 24 is plus 1. Y is equal to minus 1 by 24 second product of second row with first column, minus 1 by 24 times 14 5 is a minus 70, 6 3 is a 18 plus 4, 70 minus 70 plus 4 is minus 1 by 24, minus 70 plus 22 it is minus 48, so it is plus 2, whereas Z is equal to minus 1 by 24 product of third row and first column, minus 100 plus 36 minus 8. So it is minus 108 plus 36. Minus 108 plus 36 is minus 72. Divided by minus 22 is plus. So that is how we can directly calculate by this formula. X is equal to 1, Y is equal to 2 and Z is equal to 3. This is nothing but the matrix inversion method, which is very simplest ever method, can be asked in the examination. The same example we shall now prove by the Gauss elimination method. So friends, after solving this system with the help of matrix inversion method, let us now consider the Gauss elimination method. Again, this I am rewriting the same system of equation in the matrix form. It is written as 2, 3, minus 1, 4, 4, minus 3 and 2, minus 3 multiplied by matrix of unknowns, that is equal to, we have a matrix of 5, 3 and 2. Now what is the Gauss elimination method? Here matrix is like this, AX is equal to B. The Gauss elimination method is converting or transforming the matrix A colon B, it is denoted by matrix notation. This matrix A colon B is obtained by appending the matrix B to matrix A. We shall convert this matrix into an upper triangular matrix. Upper triangular matrix is lower triangular entries, they are 0. And after converting this into upper triangular matrix by backward substitution method, we can simply easily solve the system of equation. Question is, what is this matrix A colon B? Here, matrix A matrix A. This is matrix A. 2, 3 minus 1. 4, 4 minus 3. 2 minus 3, 2. I am adjoining matrix capital B to this. 5, 3, 2. So this is nothing but our matrix A colon B. And I shall transform this matrix A colon B into an upper triangular matrix by elementary row transformation. Converting the any matrix into upper triangular matrix means convert all the entries below A11. A11 is first row, first column entries into 0, number 1. Convert all the entries below A22 means second row, second column. Convert them into 0 and likewise. So I shall transform this 4 into 0 and this 2 into 0 by row transformation. So first row is 2 minus 3, 1. So how shall I transform this 4 into 0 and 2 into 0? Simply I shall subtract 2 times first row from second row and first row from the third row. So R2 changes to R2 minus 2 times R1 and R3 changes to, I am transforming R3 from R3 minus R1. So that matrix becomes, I am not changing the first row which is 2, 3, minus 1 and 5. Now R2 minus 2 times R1. So 2 times 2 it is 4 minus 4 it is 0. This element is 0 now. Now 4 minus 6 minus 2 minus 3 minus 2 minus 3 plus 2 minus 3 plus 2. Now 3 minus 10 minus 0. Now 2 minus 2 it is 0. I am subtracting row 1 from 3. Minus 3 minus 3 minus 6. 2 minus 1. 2 plus 1 it is 3. And 2 minus 5 is minus 3. So this is not, however, an upper triangular matrix. I have converted all the entries below A11 as 0. Now I shall convert the entries below A22 as 0. This I shall convert it into 0. So how shall I convert this into 0? Obviously R3 changes to, I shall subtract 3 times R2 from R3. R3 changes to R3 minus 3 times R2. So first 2 rows there as it is, 2, 3, minus 1, 5, 0, minus 2, minus 1 and minus 7. So 0 minus 3 times 0 it is 0. Minus 6 minus 3 times minus 2 is minus 6. Minus 6 minus 6 is 0. 3 minus 3 is 6 again, and minus 3 into minus 7 plus 21 minus 3 is 18. So that is how this system is nothing but an upper triangular system. And question is how to determine the solution. It is determined by backward substitution method. Go to the third row. What is third row? This is 0x plus 0y plus 6z equal to 18. By backward substitution. This 6z is equal to 18. That gives me z is equal to 3. Z is 3 here now. And from the second equation now, second row, sorry, minus 2y minus z minus 3 is equal to minus 7. So 2y is equal to minus 3 plus 7. Therefore y is equal to 2. Now from the first two, 2x plus 3y is 6. This is 3y. Minus z. Z is 3. 5. Therefore 2x is equal to 5 plus 3. 8 minus 6 is 2. So x is equal to 1. The same solution we have already obtained in case of Gauss, matrix inversion method. So yes, x is equal to 1, y is equal to 2, and z is equal to. This is the required solution to given system of linear equation. Both the methods we have discussed. The example was same. So hope you have understood this method. Both the methods are quite simple. In earlier we have determined x equal to A inverse B, whereas in this Gauss elimination method we have convert this A colon B into upper triangular system and use this backward substitution method. So thank you very much. Now friends, I am giving you some examples for homework. So hope you will solve these examples at home and show it to me in the Google Classroom. Okay. So solve the given system of equation. Solve the following. Linear system of equations. The first system is x plus y plus 5z equal to 16. Two x plus 3y plus z equal to 4. 2x plus 3y plus z equal to 4 and 4x plus y minus z. 4x plus y minus z is equal to 4. Second example, x minus y plus z equal to 6. X minus y plus z is 6. 2x plus 4y plus z equal to 3. 2x plus 4y plus z equal to 3. 3x plus 2y minus 2z. 3x plus 2y minus 2z is equal to minus 2. 3x plus 2y minus 2z is minus 2. The third system is 2x plus y plus 4z. 2x plus y plus 4z is 12. 2x plus y plus 4z is 12. 8x minus 3y plus 2z is 20. And third equation is 4x plus 11y minus z. 2x plus 11y minus z is 33. And last example is x plus 3y plus 4z is 1. X plus 3y plus 4z is 1. X plus 4y plus 3z is x plus 4y plus 3z is minus 2. Fourth example, third equation is x plus 2y plus 8z. x plus 3y plus 8z is equal to 4 by, you have to solve all the 4 examples using both the methods, by matrix inversion method and Gauss elimination. One of these examples will be definitely asked in the forthcoming unit test. So do this homework very sincerely, carefully.